Hey, welcome to day 4 of camp. As always, I'm here with my camper, McKinley. Let's say good morning, McKinley.
Hi. Morning.
McKinley's going to help us do a demo here in just a sec. What we're going to make today is we're going to make a little remote control car. So it's good, even if it's simulation, to learn about motors. So today's focus is going to be about motors. And we've got a little demo for you. Sis, you want to be the driver for the demo?
Of course.
So what we've got set up here is we've got a little remote control car. So we're going to be learning about motors in simulation. But we've got motors connected to the bottom of this board. It's just something this kit can do, which is fun. We're going to be controlling it with remote control. So Sissy, go ahead and send an F for forwards. Great. And send B for backwards. And then go ahead and try an L for a left turn. And then an R for a right turn. And then just to be silly, send like 3 Bs or something to make it go backwards 3 times as much. We'll see if we can catch it before it falls off the table. I always recommend to students that they use the floor whenever they're doing things with wheels, but we're just kind of doing it on the table. I've also got my speed set to super duper slow, just so that it doesn't fall off the table. But obviously,
It's
whenever
gonna fall off the table this time.
whenever, oh no, hit it, sis. Oh no! You'll find that when it comes to kids and remote control cars, there's always a desire to make things crash. All right, let's go ahead and get started. Back over to your seat. We'll teach you how to make motors go. you gotta figure out how to make this silly car stop. Maybe I'll just upend it.
Unplug it from power, I bet.
Yeah, I suppose I could unplug it as well. Thanks so much for your help there, sis. All right, so let's go ahead and get started today. So this is the finished circuit that we're building. So we'll build it piece by piece. Looks like I do need to kill power on this thing.
Mm-hmm.
All right, so I'm going to go ahead and head over to my dashboard so that I can make a new circuit. So click on New Circuit. And the first pieces that we're going to add are things that we've used quite a bit. We're going to add a breadboard and we're going to add an Arduino. So there are some cool starters that we can use, but I kind of like to just start from the basics. So I'm going to single click on breadboard. I find that sometimes single click works better, and then single click over here. Sometimes I try to drag it over, but I forget that Tinkercad works better with just like you click it, then you just kind of wait for a second. And then you drop it over here. And so what we're going to do is we're going to add these 2 components. They're going to be principal things we're going to do. We're also going to add some motors. There's a bunch of different motors, even in Tinkercad and certainly in the real world. The ones that I'm going to add are these hobby motors. These are fun. These come from a company in China called Daegu. They are inexpensive. You can buy them on a number of different sites. I think I got mine from Robot Shop once upon a time. This kit came with a couple, right? But they're really good for making like cars and things like that. So those are some things that we're going to use. Other pieces, just kind of while we're getting our big pieces together, it's always nice to, when you deal with motors, to be able to control the speed to like make it go a little faster, a little slower. And a good way to do that is with a potentiometer. So you can always change speeds in code, but it can sometimes be nice to have a potentiometer on the board. So I'm going to add 2 potentiometers, one that kind of controls the speed of the right motor, and then the other that controls the speed of the left motor. Now in simulation, you could control the speed with a single potentiometer, and they both like go faster or slower together in simulation. But in real hardware, every motor is different, especially at super slow speeds. So you really do need 2 potentiometers in a real system so that you can like make the right go a little faster or the left go a little faster so that it drives in a fairly straight line. So those are good things to add to our circuit. So now we've got our 2 motors, we've got our board, we've got our Arduino, we've got our trim pots so we control speed. The thing we're missing is we're missing electronics to drive the motor. So in the same way that like, you drive a car, all you do is you press the gas pedal, which tells the car, hey, make the big motor go. You don't like get out and push, right? Like that's not how it works. With electronics, motors take a lot of power. They take a lot of oomph, right? And the microcontroller is not made to do that. The microcontroller is just made to push the gas pedal, right? And so he needs something else to make the motor go. So that was a big long speech to say something that we need is a transistor. Now there's a couple different types of transistors. One of them is called a MOSFET, M-O-S-F-E-T. We're not going to use a MOSFET today, but I want to tell you about it real quick. It's a type of transistor. It stands for like metal oxide semiconductor field effect transistor. That might be right. I don't even know. And that is a good type of transistor. They're very popular at turning something either on or off. So if you wanted your car to go in just forward, right, then a MOSFET would be great because it could turn the motor on or it could turn it off. But what it doesn't give you the ability to do is reverse, right? And we want reverse. We've got a car. There's also an NPN transistor, but I'm not going to get into that either. The other thing that's good is called an H-bridge. So an H-bridge is a chip. So it's a little chip that you put on your board. They come in all different flavors, and we are going to use an H-bridge. So I'm going to single click on the H-bridge, rotate it a couple times. And the way these chips work is you plunk them right down right into the middle of your breadboard. And so this H-bridge chip has a lot of pins on it, right? So it's got a lot of different things going on. I'm just going to kind of tell you how do we connect it, but I'm just going to tell you the short summary. One side of the H-bridge controls one motor. The other side of the H-bridge controls the other motor. That's kind of like the big picture. And I think that we're ready to start doing some wires. Oh, actually, one more piece. So motors take a lot of power, right? Sissy, do you like motors? They make me feel like right? They need a lot of power. And power comes from batteries. So this won't affect the simulation, but I'm going to do it anyway. I'm going to put on an external battery. So this guy actually has external batteries on the bottom so that he can have more power than just what the computer provides. And typically what you do is use 4 AA batteries. So I brought over a AA battery. And this big power pack is going to drive the motors instead of just using my computer to do it. Just to kind of organize my circuit a little bit, I'm going to put it kind of like up above my breadboard. If you lay your parts out just like mine, it might make it easier for you. But obviously where the parts are at doesn't really matter. I'm just trying to like keep things that are on the left, and things that are on the right. And that way I'll kind of like build my car. Since I just put this big power supply up here, let's go ahead and connect it. So the first thing I want to do is I want to connect ground to ground. I like for my ground wires to be black, just to like make them easier to see. Colors of wires don't matter, but I like for my grounds to be black. And the way that I did that is after I put the wire, I hit the 1 key, which is a shortcut key to select black. Likewise, I'm going to connect my power, and power is red. So I'm going to connect that wire and then hit the 2, so that connects my power and ground. So my big power is on this rail, and then I'm also going to put my little power on the other rail. So I'm going to connect ground from here to here, and that one's going to be black. And then I'm going to use the 5V to connect little power over on this side. Now, we're just kind of learning about electronics, and we're like, why do we have 2 different power supplies? Well, this is, big power, which is like 6 volts, and more than 6 volts. It can provide like up to over an amp of current. And this is little power. It's 5 volts, and it can only provide like 100 milliamps of current. So big power, little power. Now, regardless of how many powers you have, you still only want 1 ground. So do this for me. Click on the ground on this side. And what I'm going to do is I'm going to connect ground to the bottom of my breadboard. And so what that says is, I've got a big power and I've got a little power. So that's great, but there is only 1 ground. And this is true for all electronics. You only want 1 ground on things. Now we're ready to start connecting our chip. So our chip here wants to drive the motors with big power. And the pin that you need to connect on this chip to big power is the lower left corner. And if you want, sometimes I like to bend it around. That's completely optional, just so you can kind of see that it's going to big power. And then little power goes into the top right. And the way this chip is designed is that it wants little power so that it can do its internal functionalities correctly, just like a microcontroller needs power. And then it needs big power because it'll use that with some transistors it has inside to drive the motors with big power. Another thing these chips need is they need a lot of ground connections. And so all the middle pins, so 2 on the left and 2 on the right, all need to get connected to ground. Now you're like, that's silly. Why do I have to connect 4 different pins to ground? Because really a chip only really needs 1 ground. But it's because of there's a lot of power things going on here, and they wanted a really good path to get to ground. And so that's why there's 4 of them. It also made the packaging work out better back when they designed this chip many decades ago. All right, so that's kind of the gist of it. The next thing we need to do is we need to connect our motors to this thing. So let's go ahead and connect the left motor to the left side and the right motor to the right side. So here's what I'm going to do. I'm going to take a pin just above ground, and I'm going to connect it down to my motor. Now these wires can be any color. It doesn't really matter. A lot of places show them as like black and red, but they're not black and red. I actually dislike that these are labeled black and red, and they're labeled black and red because the real car, they're black and red. But motors don't have a black and a red. Motors have an M plus and an M minus, because if you put power through one direction, it spins one way, and if you put power in the other direction, it spins the other way. So really, they shouldn't be black and red. They should just be like white and blue or something like that. But you know, that's fine. So to emphasize that, I'm going to make the wires that go to them just be blue. Looks like my wire kind of goes under the motor there, and it looked like it was disconnected, so I'm going to move it over just a scooch. So that is how we connect the motor on the left side. We're going through things kind of fast, but you can always pause the video if you ever need. Poor McKinley over here. She's desperately trying to keep up with me. She's doing good. Now we got to connect the right side motor, and it's very similar. It's symmetric, which is nice. So I'm going to bring him down here. And when it comes to running wires, you can see that I always like to try to like run them a certain way, but there is no wrong way to run a wire, right? I'll have to take a look at McKinley's board when we're done here. I predict that she doesn't bother with all the little movements that I tend to do, right? Cool. So I think that's looking pretty good. All right. Now I was watching McKinley over here, and she was trying really hard to figure out. It's like, does this bottom wire go to the black, and then does the bottom wire over here go to the red? And she's like trying to make sure that she gets it just perfect. It turns out that I don't care how I put these wires in. It's easier, I guess, if you do it the exact same as me, so we can run into the same problems. But when I'm wiring a circuit like this, I just plug in the wires into the right spots, and I don't care if I get things crossed, because the worst thing that happens is that my motor goes in reverse when I start running. And if it does, I'll just change the code to fix it, right? So literally, I decided where to connect this wire, honestly, wherever it would make my circuit prettiest. But if you swap them, it doesn't really matter, because you can always fix it in code later. Now, the next thing we want to do is we want to control the left motor and control the right motor. We want to control the speed that it goes at. And so there's one pin that's like, how fast do you go? And so it's kind of like a knob that you turn. And then we want to control the direction. We either want to go forwards, backwards, or reverse. Since there's 3 options, forwards, backwards, or stopped. Since there's 3 options, we actually need 2 pins to do that. So like it could be like 1, 0, because it'll go one direction. 0, 1, it'll go the opposite direction. Or 0, 0, it'll stop. So we need 2 pins to control the direction, and then a third one to control how fast to do that. So let's go ahead and connect these 3 pins. So the first one I'm going to connect is I'm going to connect the how fast pin. So I'm going to connect the top left, which is right there, to pin 11 over here. And I'm going to choose to make everything on this side be green, just so that I kind of like don't get it confused. And if you want to try to make it pretty, of course I want to try to make it pretty. You can add bins and things as you see fit to try to pretty your wires up some. Good enough. I'll just leave it right there. So that one's going to pin 11. Now I picked pin 11. Let me put in a little dip here just so you can see it, because it's got this little like tilde in front of it. A tilde in front of a pin means that it can be used in analog output or PWM mode. So that way you can control, it's not just 0 or 1, it can be anywhere in between. And so that's why that is on one of those tilde lines. Now the other two lines, well, there's only 2 lines left on this side, it's here and here. They're going to go to 12 and 13 because they don't need the ability to do an analog right. And so I'm just going to go ahead and connect this guy to 12. And then I'll connect this one right here. See if I can work my way around this guy to 13. So I've got 3 wires that control the left side, and one of them is special. It's like the how fast, and it's in the upper left of the chip, and it's going to pin 11, which has that little tilde symbol, right? I'm going to go ahead and connect my other wires while I'm here, just kind of while I'm in wiring mode. And the right side, the lower right, controls his speed. And I'm going to connect him to pin 3. And just to kind of like make him all the same, maybe I'll use yellow wires for him, right? Now I chose to connect him to pin 3 because pin 3 also has one of those little tilde jobbies. So if you look right there, if your eyes are super good, it's got a tilde jobby. And then the other 2 pins on this side, I'm just going to collect nearby. I see 2 and 4 are available. So I'm just going to connect one of these to 2 and then the other one to 4. So now I've got my control line set up. So the microcontroller's whole thing is he controls what the H-bridge does, and then the H-bridge is in control of driving the actual motors. And you can look at the data sheets for how these works and why these pins are put in like this. But I think it's a pretty good way to arrange it. There are different ways to arrange an H-bridge, but I'll do that. Hey, so long as we're doing wiring, let's go ahead and wire up our potentiometers. Our potentiometers, on the top, we're going to put a connection to power, and on the bottom, we're going to put a connection to ground. And I'm going to use little power for this because I don't want to like drive a motor or anything. I just want to be able to do control things. So I'm going to take the top to power, the bottom to ground on that one and on this one. And again, you can see I just connected the power to somewhere in this row, and then the ground to somewhere in this row. And then here the top is to power, the bottom is to ground. All right, so let's connect our last 2 wires. We want to connect the middle of this potentiometer, this is the analog signal, to A0. Doesn't matter what color wire you make it. I feel like purple, just because purple's fun. And then I'm going to connect the middle of this one to A1. Pretty impressive circuit that we've built here. So we've got 2 potentiometers, which we're going to use to control the amount of the speed. We've got 3 control lines for the left motor, direction and how fast, 3 control lines for the right motor, and then we've got the motors connected down here. And then we've done some things to like have big power and little power, right? People also call it unregulated power and regulated power. So now we're ready to see if we've done anything useful at all by testing it in code. So the first thing I want to do to save it is I want to call this my remote control car. When you change the name and you type in your new name, so here remote control car, it does automatically save it. You can see up here it says all changes saved. All right, so let's dive into code. Now when it comes to the code, we've got a lot of things to test, So let's go ahead and we'll just kind of pick where we want to start. We're going to do everything with text today, so go ahead and switch it over to text mode. Are you sure you want to switch to text? And I'd be like, yeah, that'd be fine. And I don't want any of their current code. So nothing that they put on here is useful for us. It was about flashing LEDs. We did LEDs and push buttons our first day on Tuesday. The second day, by the way, we did analog, so you should already know about those, and LCDs and servos. And then today we're doing motors. I'll tell you what, since we already know about analogs, maybe we'll start with those. So the first thing I want to do is I want to make some variables. I'm going to make a variable called left pot and right pot. They're going to both be integer variables. And what I'm going to do is I'm going to read the left pot and right pot, and I'm going to print the values just to make sure that the values kind of look good. So there's my two variables, left pot, right pot. Normally with a pen, you have to do some setup for it, which would be in the setup area, but there's no setup for analog input. That's the default, which is nice. So I'm going to say my left pot, and I'm just going to type this fast. You can pause it if you need, is an analog read, and we got to figure out where he's connected to. So my left pot right here, if I trace the wire, he is on A1. So I want to do an analog read of 1. You can also type A1 in there. I kind of like just typing the number 1, and it works, so I like to do that. And then we'll do an analog read for the right pot. This is my right side pot, and he's connected to A0, so I'm just going to type in a 0. Now, just to make sure that it's working, I'm going to print the value to the serial monitor. So you can see where it says serial monitor down here. So the serial monitor is communication while the program is running, communication between your computer and your Arduino board. So it's kind of interesting that your computer is used to program it. So like you send the program over and then you're done with it. But you can also communicate with it while it's running through the serial monitor. And the serial monitor is new today, and we're going to spend a lot of time with it, right? So the first thing we have to do to use the serial monitor is we have to type a command called serial begin. Whenever you do serial communication, you have to decide how fast it's going to go. And so your computer and your board have to be speaking at the same speed to hear each other. If you just talk at different speeds, it doesn't work. This number right here is 9,600 bits per second. So they talk fast, right? So they're talking like, they're saying like 10,000 things a second. If you talked and said 10,000 words a second, it would go very badly. And what I want to do is I want to print out those values. So what I'm going to do is I'm going to print, I'm just going to make a little message here. I'm going to say L is equal to, and I'm just going to type the whole thing here, and you can type it at whatever speed you type. L is equal to left pot. And then I'm going to type R is equal to right pot. I'm certain that you type at a different speed than me, but I have no value in typing it slow, so I just do it fast and then you can catch up. Now, what I want to do is you'll notice that these are all print statements, so they stay on the same line. I want the last one to go onto a new line. And to make something go onto a new line, you can put this LN on here. It sends the new line character at the end. So that way, all four of these things, the L, the left pot reading, the R, the right pot reading are on one line, then it'll go to the next line. Now, if I just did that, it would print out super fast. So what I'm going to do is I'm going to put a delay in here of 1 second. Now this code is really just test code. It's to see if our potentiometers are hooked up correctly. And if it works, then my goal is to delete it all when we're done, right? But that's my goal. So I'm going to go ahead and run mine. You'll have to pause the video as necessary to get yours to work. But I'm going to click on Start Simulation. And right now, I'm printing things to the serial monitor. So I've got to see the serial monitor. So I click on Serial Monitor. And you can see that it's printing out L0 and R0 all the way. If I switch this guy to like in the middle for the right one, you can see that it says 511. That's right at the middle. Good job, me. And if I click it like all the way up, like near the max, it should be 1023. Left should also be movable. So there it's 1023. And then there it's 511. And then here it's, well, it looks like it's about 164. Again, it's important to note the range of these things. They go from 0 all the way up to 1023. Now, it turns out for motors, you're going to also run in the same range from 0 to 1023. They run about as fast as they're going to run. Anything like 300 above, they all run about the same. That's just a feature of motors. And if you want to run it lower, you kind of have to go somewhere in this range. So I'm going to put mine like straight down. And so straight down is going to run at kind of like a middle speed, right? So it's going to run at kind of a middle speed. Now it depends on the motor. Now the nice thing is that we are using simulated motors and they work perfectly, but that's going to be a good speed for a lot of real motors. By the way, you'll notice that the motors have a little indication on them here. They say 0 RPMs, that's 0 revolutions per minute. All right, so my analog inputs work. I'm quite confident that they work. Once I'm confident that my code works, I sometimes just comment it out, right? So I know, it's frustrating. It's like I just typed all that code and now you're telling me to comment it out. Very common to test some small piece, see that it works, but we don't need to be printing all the time. So I'm gonna take it out and then to kind of move on to the next piece. All right, so it's time to test some more hardware. It looks like the next thing we need to do is we need to start tackling our motors. So we're going to start by laying a little groundwork for our motors. So functions are things that you can call. So for example, here's a function, analog read 1, analog read 0, another function for delay. What I wish we had is I wish we had a function where we could just say like left motor, and we could just give it a number. We just say like 500. And I wish we had a function that just said right motor, you go at negative 500. And if we had a function that we could just do things like that, then our motors would be much more useful, right? Because we could just say, go at the speed. So like 500 would be like a middle speed, negative 500 would be like a middle speed, but in reverse. If I wanted to stop it, I could just say, stop, 0, right? So I wish that those functions exist, or I wish that they did exist, but they don't, right? And so we have to write that function. And the reason they don't is obviously people could write them, but everybody's different, right? So where you hook up your wires and things. So we're gonna make those functions. So we haven't made functions yet, but they're extremely powerful. And we're gonna make these two functions. We're gonna do left together, and then we're going to have you try to do the right one by yourself. So I'm going to make a little space here. So this function for left motor, it's going to take in one, what's called an argument for speed. This argument that it takes in, so here we called it and we said, hey, left motor, go at 500. This is what the syntax looks like in C to make a function. It's kind of confusing, by the way. But it's saying here that we're passing in 500, which is an integer. And whenever we pass in that number, it becomes the value speed. So don't type this, but I'm just going to say, so if I said serial.println speed, it would print out 500 in this case, right? Because I passed it in as speed. And if I put in, like 50, then of course this print would print out 50 because speed becomes 50. You get the idea. All right, that was just an example. So what we want to do is we want to drive the motors depending on the value of speed. Now the first thing we need to know is we need to know if speed is positive or negative. So if speed is positive, we'll do one thing. And if it's negative, we'll do something different. And if it's 0, we'll do something even different. So here's how this works. So if, so use a lot of if statements in coding. If speed is greater than 0, then run the lines of code that I put in here. Before I put that code in, I'm going to do some more things. If speed is less than 0, do this stuff. So the syntax is hard, but the concepts are what I care about you learning. So if it's greater than 0, do this stuff. And then else, meaning if it's not greater than 0, check to see if it's less than 0. Now, there's one number that doesn't satisfy either criteria. So if it's greater than 0, do that. If it's less than 0, do this. Sissy, have you figured out what the other number is? What's the other number?
I'm too busy trying.
Too busy trying. She's panic trying to type. The other number is 0 itself, right? So if it's bigger than 0, do this. If it's less than 0, do this. And if it is 0, do this. So those are kind of the three situations. And so that is go forwards, go backwards, or stop. Those are kind of our three options. Now we've got to figure out how do we go forwards, how do we go backwards, how do we stop? And the way we do it is we do digital writes to our different control pins. So I'm going to say digital write. This is my left motor, so these are my green lines. So the digital ones are, it looks like 12 and 13. So I'm going to say 12, go high. And 13, go low. So what that will do is, those are my two control lines. Remember I said how if one of them's 1 and then the other is 0, then it'll go in that direction. And then if you want to go in the opposite direction, I'm just going to copy those two lines and I'm going to switch it. I'm going to do a low and a high. Again, I'm typing ludicrously fast, but that's because with the beauty of videos, you can pause it, right? So, so that's kind of the idea. So if it's going forwards, do a high and a low. If it's going backwards, do the reverse, a low and a high. So you do the exact opposite. Now, if you're not moving at all, so if you're stopped, so I'm going to copy this down to the stopped area, we just bring them both low. You could also bring them both high. That also works. If they're the same, it stops it. The one's called coast, the other's called brake, but it doesn't matter. That will stop it. Now, the thing we've neglected here is how fast do you want to do that, right? So we can do better than just go. We can actually like set the speed. To set the speed, we have to do an analog write. The analog write is a different command, right? And analog writes are only possible on pins that have this little tilde in it, right? So it says somewhere on here, or at least a real board it does. Yeah, so PWM is a tilde, right? And so analog write, if you send 500, that sends like roughly 2.5 volts, and we can control the speed. So each time I want to control the direction, and I also want to control the speed. Now in this second case, since speed is negative, I have to put a negative sign in front of here. And the reason for putting that negative sign in front of there is because two negatives make a positive, right? So if it was negative 500, then I do this to control the direction. But then the thing I actually analog write is always a positive number, so it's there. And then our last case, doesn't matter what we put in for speed. It's actually ignored, but I like to be thorough. So I'm just going to put an analog write of 0. Now I've written a bunch of code here, and I have not worried about direction at all. And the reason I haven't worried about direction at all is because I can always change it. Let's say that my wiring is such that, 12 and 13, high, low, actually make it go reverse. I can always just change it later. I didn't worry about it because I'm just going to test it and see what happens, and then I'll go from there. All right, so I think I've got some code that's ready to test. Before I test it, I'm going to comment out this call to write motor because we haven't written that function yet. If you try to call a function that doesn't exist, bad things happen. So the first thing I'm going to do is I'm going to show you what happens if you have made an error. So I'm just going to intentionally make an error here. Maybe I put a bunch of E's in speed that time. The way you check it for errors is you just click run, and if it has an error, you see a bunch of red. Nothing wrong with red. Red is part of coding, right? So I'll fix that one. Now let's see if I made any accidental errors. So I don't have any accidental errors, which is good. So now what I want to see is I want to see if my motor is spinning or not, right? And so it looks like my motor is currently humming along with the code that I put in. It's running at 152 RPMs. It kind of fluctuates between 152 and 153. They just kind of put that in the simulation for fun. Let's run it a little slower and see what happens. So let's stop the simulation. Let's run it at 100 and hit start simulation. And whenever I run it at 100, you can see that it's running quite a bit slower. Now we went to all the trouble to make this potentiometer. Let's run the left motor at left pot speed. That'll be kind of fun. So now it'll run at whatever speed the potentiometer is getting. Now this is interesting. It says 0. Why is it 0? That's like a real question. Sissy, why is it 0? I don't know why it's 0. All right, so mine is really freaking out. So the problem, so I made a mistake, right? Just straight up, I made a mistake. But I'm going to just kind of figure it out with you. So when it's all the way down at 0, when I speed it up a little bit, it looks like it's going at 100 and something. And I speed it up a little bit more. It's going faster, so that's good. Speed up a little bit more, and boom, it just drops to like 6 or something. I'm pretty sure, we'll test this, that the problem is, and I just made this bug legit, that's how programming works, I forgot to set any of these pins as outputs, right? So I got lazy. So for analog inputs, you don't have to set up anything. But for other things, you got to set up the pins, right? And so I think that almost certainly what's wrong is that I didn't set up any of the pins to be outputs. And that's what's really causing this thing to freak out. So I've got 6 output pins here. I've got 11, 12, and 13, which are for one motor. And then I've got 2, 3, and 4, which are for the other motor. Now I'm not using that other motor yet, but it really was messing with me that it wasn't working right. I think it's just that they weren't actually set as outputs. All right, so let's try this out. So I start slow, and then I move up, and then it gets faster. It gets faster. Oh, and then at some point it goes slower again. I made another bug. It's all about bugs today. Here's the bug. Easy to fix. The speed right here doesn't actually go from 0 to 1,000. It goes from 0 to 255. That was a goof on my part. So I've got to change something. Since I want to use the pots, here's what I'm going to change. Inside of here, I'm just going to do a divide by 4. And that's because analog write goes from 0 to 255. I forgot that's how Arduino worked. Not 0 to 1023. So I'm just going to do a divide by 4 right there and a divide by 4 right there. And life will get quite a bit better. All right. Sorry, made multiple bugs there. I could refilm, obviously, but I choose not to because bugs are part of how things work, right? So now things should work better. So my left pot is down here. It's going at like 24. And then as I speed up a little bit more, it goes at like 70 or 80. As I speed up even more, it goes at like 130. And then my max speed is about 160 for this motor. So now my range is much better. Cool. So that is now some successful code. Whew, was that painful, Sissy? Hey, that's how.
Much because you did all the work.
That's how it really goes. But I did fix and get the output set up, and I did fix to get the speed set up there. All right, now what I want you to do is I want you to set up the same thing on the right all by yourself. So I want a function called write motor. And write motor takes a value that goes from 0 to 1023 is technically the range. I usually just do a 0 to 1000 because it's much cleaner. And it's going to control the 3 pins on this side. So it's going to control pin 4, pin 2, and pin 3. And pin 3, as you can see, it's the analog one, right? So see if you can follow the pattern of left motor and make it for right motor. And really the thing that's going to change, the big thing that's going to change is the pin. So instead of being in 11, 12, and 13, where 11 was the analog, now you're going to be in 1, 2, 3, where 3 is the analog. So see if you can make that happen. All right, so I wrote mine, and the way I did it is I cheated, of course. I copied my other one, and just anywhere where I had an 11, which was the analog, I switched that to the 3. And anywhere there was a 2, I made that, or 12, I made that a 2, and anywhere there was a 13, I made it a 4. Now, there's entirely a possibility that my motor is going to go backwards as soon as I run this. That's okay. I'm not too worried about it. I will just let it happen, and then I'll fix it if I need to fix it. I'm going to choose to call write motor with the right potentiometer and hit start simulation. Cool, and so now it should be running.
Go away.
It looks like it's doing pretty good. I'm going to hide the code here just so I can see it. And so right now my left motor is stopped again, but that's just because I left the potentiometer down all the way. So I could run them at max speed. So it's like 150, 160, and run this one at max speed. And I've got a cool little program here. Now what I'm going to choose to do is I've got the actual hardware. So I'm going to go ahead and try this program on the actual hardware. And so what this is going to do is this is going to make my car like drive around, which would be fun, right? So Control A, Control C. I realize that it's unfair that I have the hardware here and you don't. But I like to show you, oops, got to plug my hardware in. I like to show you what it is that you're making like on a real car. And so we'll go ahead and try some things with the actual device. All right, so I've got mine programmed on here. Let's try it out. So what it should do is we put it on a table. It should go at a certain speed, which is good. And then if I take these potentiometers and I just crank them up, it should go faster, which is fun. And if I take these potentiometers and I turn them way down, then it's like barely going at all. And it's going so slow that it may not even work when I put it on the table. But yeah, see there, it's going super slow. Cool, and so you can see that our code does work on a real car, which is fun. And we've learned how to wire motors. All right, so this last part is optional. If you want to call this video done here, you can. I probably would have taken this 1,000 down to something smaller. But if you want to call it done right now, you can be done. But I'm going to show you some other neat thing that we can do with serial monitoring. So serial monitoring, you can send messages to your car, and you can also print things from your car. And what you can do is you can actually, instead of just always going at these speeds, you can listen for the serial monitor. So I'm just going to go ahead and type this, and then I'll talk about it. So if there are bytes available, like from your computer, if your computer sent some bytes over, then we can see what your computer sent over, and then we can respond accordingly. And so what we can do is we can receive a byte. So this is the message from your computer. So we're going to say serial.read. And depending on what your computer says, so like maybe your computer says forwards, then you can do things appropriate for forwards. So type that really fast. You can pause it and get caught up. But if they send a message for forwards, then what you might do is you might make the car go at whatever your potentiometers say to go at, right? And you can do as many different commands as you would like. So that one's forwards. Let's say that I wanted stop, right? So if I say stop, then I can make them both go at 0. And I think that that's enough to try it, right? So now I can turn my motors on to go at the potentiometer speeds or stop. So if I hit start simulation, what's happening right now is nothing's going yet, but I can click on my serial monitor and I can send these messages, right? So I'm going to clear off my old messages. So I'm going to send a capital F, and if I hit send, then both my motors start going at wherever their pots are set. And if I send a capital S, that makes them stop. And that's what we were kind of showing with a real car at the beginning. Now you could improve upon this a number of different ways. Again, all optional. But you can do as many commands as you'd like. You can also, to make your program easier to debug, you can respond backwards with things like forwards. So this is the Arduino microcontroller responding back a message. So if you do like a forward, so respond back, hey, forwards, and then it'll do it. If you send S, it'll send back, hey, stop, and then it'll do it. If you want to, you can make as many commands as you'd like, right? So maybe I'll make a left, that'll say left, and left will make the right pot go. So you turn left by making the right wheel go. Right, and you do the reverse for right. You make the left wheel go and then back it up, which normally I would call reverse, but I've already used R. So back up. And then there you would go at negative of the left pot and negative of the right pot. By the way, on these turns, if you'd like, you can also make it spin in place. So you can make, like, instead of the motor just stop, you could make it go negative, which would be in reverse. Again, typing things at beyond ludicrous speed there. So there's no way that you can keep up in real time. But you can see my code. And if you'd like to try it, you can type it in and you can see how it behaves. I think it's good to kind of get an example of it. But if you did want to just watch, it is kind of a mountain of code. I do want to try it to make sure that it actually is working for me, though. So I start the simulation. I say forwards. It's got to be a capital F, so I'm going to say forwards with a capital F. That works fine. I'm going to say stop. That works fine. I'm going to say back it up, and back it up makes them both go at negative and negative. If I do a left spin, then my left one goes backwards, my right one goes forwards. If I do a right, it does the opposite. And then if I do, a stop, it'll stop it. I could show this on the car, but I think we're starting to get kind of long. And it's the same as that first demo. Now, the downside of this demo is that you will have to, if you use a real car, keep your cable plugged in, and then it will make your real car go. All right, so this one was all about motors. We saw how to wire the motors. It was a little bit longer. Sorry about that. But Sissy, do you think that some of these things were cool? Mm-hmm. Were you a little bit spoiled because you got to play with an actual car, whereas other people only got to do a simulation?
Just a little.
Just a little. Cool. So I wanted to show you about motors. Motors are an important thing to do if you kind of get into the hobbyist world. Tomorrow, what we're going to play with is we're actually done with circuits. So this was our whirlwind Tinkercad circuits. Tomorrow, we're going to do something new in Tinkercad called code blocks, and it'll be kind of fun. We look forward to seeing you there. Bye.